Now we will discuss what is density-based clustering is. See, density-based clustering will use algorithm called DBSCAN algorithm. See, generally this clustering is an unsupervised learning, right? So whenever we are forming the cluster, when the data set is given, whenever you're forming the cluster, we usually find the similarity between the objects, and whatever the objects which are dissimilar, we'll keep them away from that particular similar objects. That is what this cluster mean, right? See, but in case of density based clustering, what it will do, it will calculate the density, the region densities of each and every point in the space. So this DBSCAN algorithm mainly used to avoid the noise within the data set. See, let us see how this algorithm works. Before that, why we need to use this particular DBSCAN algorithm? Already we learned about what is partitioning methods as well as hierarchical methods, right? So why we should go for this particular algorithm? See, the main motto is that even though those algorithms are very effective, so they are unable to remove noise from the data. So there is some outliers in the data. So to overcome that particular thing, as well as these two algorithms are used only for convex clusters. So they are not used for arbitrary shaped clusters. So that to overcome these two disadvantages, we came with the DBSCAN algorithm. So let us suppose that this is the data they have given on the space. See, this is, if you see this, you can assume that this is a non-convex cluster, right? See here, we can able to find these are the noise elements. We can consider this as outliers, right? See, using our k-means or k-medoid, we are unable to find out these objects. So that we are moving on using DBSCAN algorithm. So the basic requirements of this particular algorithm are two parameters. First thing is epsilon and the next thing is min point. What is meant by epsilon? See, in the space, they will be given some data points. See, how many data points we have to consider in a particular radius. So that radius, whatever the radius, we are considering it as a epsilon. Epsilon is nothing but how many neighbors we have to consider in a particular radius. That radius, you can call it as a epsilon. See, make sure that this epsilon value you are choosing it in a very careful way, because if you choose epsilon value is very small, no, so if your epsilon value is very small, all the data elements will be considered as outliers. If it is too big, what will happen? All the elements you will be considered as a cluster. There is no noise. You will be considering every element into a consideration. So what you have to do, you need to make sure that whenever you're calculating epsilon value, you are using k distance graph. So that is the best approach. So after calculating after finding epsilon value, you move on to the min points. See, you know the value of epsilon. That means that you need to know the radius, right? Now, within the particular radius, how many neighboring elements you wanted to consider? So that number of neighbors can be called it as a min points. So the number of neighbors depends on number of attributes in a given data set. See, let us suppose say if you have taken weather data set, no, it is having 4 attributes, right? Likewise, based on the attributes or the dimensions within the data set, min points will be, the number of min points will be calculated. Let us suppose say D is the dimensions. So min points value should be greater than or equal to D plus 1. So generally it will be treated as 3. At least you should choose it as a 3, but it should be greater than or equal to D plus 1. Now, after calculating the main two parameters for DBSCAN algorithm are epsilon, that is nothing but you're finding the radius, and later on how many neighbors you wanted to consider within that particular radius, you can call it as a min point. Now, after calculating these two, you need to find out 3 points where core point, border point, and noise are outlier. See, what is meant by core point here? See, a point, let us suppose say within epsilon radius, if you are having neighbors more than min points, in those case, you can call it as a core point. Let us suppose say if you consider this point where epsilon radius, you are considering it as 1 unit. And within this 1 unit, you will be having 1, 2, 3, 4, 5, 6 elements. But minimum points I have considered it as 4, right? That means that for this particular point, within an epsilon radius, I'm finding more than 4 neighbors, so that I can consider this particular point as a core point, which means that a core point is a point which is having more than min points within an epsilon radius. Another one is border point, where it is neighbor of core point, but it is not in epsilon radius. You can consider it as a border point. As you know, noise or outlier is nothing but the other part which is not in a core point or border point. You can consider that data element as a noise. Here, this is the best example. This one. These are all the best examples of outlier or noise. So to know the DBSCAN algorithm, we need to have 5 parameters in your hand. First thing is epsilon. Next thing is min point. Later on, core point, border point, as well as noise. Now we are moving on to DBSCAN algorithm. Initially, what we have to do? You need to find out the all neighbors of a core point. Initially, you need to find out the core point. Later on, based on that particular core point, if that particular core point is not assigned to any of the cluster, you just create a cluster and assign that core point to new cluster. And recursively, you need to find out the core points for all the data elements in a data set till unvisited points in the data set found. Let us suppose say you are saying that A and B are both density connected to each other. See, what if happens? Let us suppose say you have a data, you are saying that A and B are density connected to each other if there exists a path for a point C which is sufficient number of neighbors, so that A and B are within a epsilon radius. Then only it is connected with, then only you can call these two are density connected. So this is very simple algorithm. If you know 5 definitions, those are epsilon, min points, as well as core point, border point, as well as noise. So as simple as DBSCAN algorithm is. So DBSCAN algorithm is very simple, where initially you need to find out the core points, and after finding the core points, you need to add it to any of the cluster. If there are no cluster, you need to create a new cluster and add it to it. You need to find out all the data points on the space till all the data points are visited. So this is what DBSCAN algorithm is.